All right. Hey there, folks. We are going to be doing another one of these deep dives today on what I think is probably the coolest aspect of what we've been building on this decentralized app platform. Liren is one of the primary devs. I'll let him introduce himself. I work on a variety of these decentralized systems initiatives in Block, and I work closely with Liren and some others. So go ahead, Liren.
My name is Liran. I'm a software engineer here at Block, working primarily on decentralized web nodes. And yeah, I'm also excited for today's stream. I think this is really something that sets our project apart from many of the other projects that are doing similar, data store type of situations.
Yeah, I guess what is some of the higher level concepts. But we'll also be going pretty deep in the weeds. So please do leave comments and questions as we go through this, because it gets down there. This is probably the more technical of the ones we've done. So so taking the protocol pill, the blue and yellow purple protocol pill, is I think what I hope people walk away from saying, like, wow, this is like really very different than any of these other social media protocols, very different than any of these other sort of, decentralized protocols for building apps you've probably seen. So to jump right in, we'll speed through this. The whole goal here is to build a more user-centric web, is to pull back a lot of your data, to have it locally, to sort of be able to permission it to whoever you want, to not have it be constrained in silos, to be able to mash it up, to create things that you couldn't because before your data was stuck with a bunch of providers, right? And we think that there's this paradigm shift that has to happen. HTML5, I mean, it's kind of getting old now, but this was a concept many years ago, almost 2 decades, that I had was fortunate enough to be able to work on a little bit at Mozilla, and it was transformative for the web. The web was pretty static, pretty it wasn't so vibrant. It wasn't.
I think some technical issues, Daniel. I'll take over a little bit while figure out these technical issues. But yes, as Daniel was mentioning, there was a kind of competing standards. Different browsers were working towards newer things, and HTML5 gave kind of an evergreen version to the web, so that we were able to add a lot of native things that would only be possible with native apps, were built into the browsers and things like that. And they labeled it HTML5 to just keep it evergreen, right? Like, we don't upgrade the web. We don't want websites that we built 5 years ago to need to change completely in order to still be working 10, 20 years from now. So that's kind of the idea around HTML5, and we believe Web 5 kind of will do something similar to decentralized applications.
Sorry, maybe
you're back.
Yeah, sorry about that. So we have I don't know if you covered the three topic areas or not.
I did not cover the 3 things. I just kind of talked a little bit about the evergreen version of HTML5 and how we're trying to do something similar. Web 5.
Yeah. I think what we need for the web is we need identity that's owned by individuals, and we need data, control back again, and the ability to exchange peer-to-peer when it comes to our apps and data. So I think those things are DIDs, a concept of identity that the web's never had. It's always been, someone else's ID, verifiable credentials for trust, and then personal data stores so that we can have apps where we custody data. So to kind of walk through this a little bit, what are DIDs, right? You have identifiers all the time. You shouldn't be scared of the word identifier. It can sound, like governmental, but there's really 3 words here. There's identity.
Oh no.
Every person, you have your identity in the world. Oh, did I fall out again?
Yeah, you're back. You're back.
It's killing
me. You're back.
Okay. there's identity, there's identifiers, which aren't scary. They're just ways that people can refer to you in shorthand. So if someone wants to look something up or send you an email, they're going to type in an identifier. They're going to try to locate you. That's what identifiers are about, is to locate you. It doesn't mean you as a person, right? It doesn't mean you as an individual human. It could be pseudonymous, right? A lot of people on Twitter have pseudonymous handles, but they're still identifiers. They identify a particular entity in the world, regardless of how public they are. And then other things like Reddit, usernames, stuff like that. So what do DIDs do? They replace those things, because those things you don't own. You don't own those identifiers at all. They're just manifestations of some app's database, and they're giving you like a row in that database. And so DIDs are different because you own them with keys, just like you would own Bitcoin. And they can have many keys, unlike an NPub or just a single Bitcoin key. You can have many different keys of many different types tied to your DID, and you can have control over your ID. So whatever keys you want to add, you can or remove. And also they're paired with endpoints. Service endpoints are called, and that's because you might want things out there discoverable in relation to your identity. Just like when someone looks up a web page in a browser, that's an identifier. A dnsname.com is an identifier, right? And what they're doing is they're routing to content, and you might want that for yourself without having maybe to pay $20 a year to some domain company, right? Which is centralized. So in this graphic, you can see that you can look up DIDs just like you can look up other identifiers. So the biggest, most interesting piece, I think, of the puzzle is personal data stores. We call them DWeb nodes that can support app data, do collaborative multi-peer editing of information between these data stores, replicated so they're on your phone, your other local devices, and replicated to outbound remotes of your choice. They support encryption, so you can have some data that's very private, some data that's published. So it's not an all or nothing thing. And unlike some other systems, you don't publish all of your encrypted data. It's not like you only have one way or the highway. It's like, to get my data out there seen by anyone, I've got to publish it to a completely untrusted server aggregator. You can actually host your own DWeb nodes and make them available for query of certain data you want more directly and permission that data. And they support any type of file. So unlike other systems, that might support small files, this is actually a data store. This is not a feed. It is it's more akin to something like Firebase than it is like RSS. So it supports an actual file system of sorts and any really sized binary you want. You want to talk through the slide, the sort of topology?
Yeah, so as you can see in this slide, Alice has a local DWN right on her phone. Really, can run right in the browser. It doesn't necessarily have to be its own app. The DWN is local to Alice, and she also has a remote node that's highly available and in the cloud. Because let's face it, you're not online on your phone all the time, and even if you were, your phone probably couldn't handle traffic and things like that you might need as far as sharing your data. So in this slide, as you can see, Alice looks up Bob's DID and resolves it from a DID resolver, and is able to get back a set of service endpoints and keys. And then when she wants to send something to Bob, she will send it to Bob's remote publicly available DWN. And if she's permissioned to write these types of messages, the DWN will accept it. And then Bob's home device or his computer, browser, app also will be reaching up to the remote DWN and syncing down all that data. So that data will come and reach his local device. And then when he wants to respond to Alice with something, he does the same thing. He resolves Alice's DID, is able to get back service endpoints, which include her DWN service endpoint that's highly available, and then pushes data back up to Alice. And the circle kind of keeps going that way.
And so the title of this thing is protocols, right? And so we're going to get you there. We just wanted to boot you up on all the components in the system. Now I'm going to talk about what protocols are, right? We typically think of protocols as sort of bespoke, where you're creating a protocol, a big effort to create a whole protocol that might have tons of redundancy and overlap with other things, right? And that's just generally how developers have developed protocols to date. So I'm going to give you some examples of like what we see as application typed protocols are. This is one, a music protocol, right? Something that has your playlists, your favorites, you know, tickets. It could be music event tickets in there. Your actual, you know, people stream these days, but you know, your actual MP3s, if you're still do that. I mean, I do that still. So that can all be in your data store, right? Your actual data. And you could have a local client app that's offline that runs and is able to actually provide you an experience based on all that data. So that's one example, right? And that's a protocol for music. You could have a protocol for reservations and travel and itineraries, right? An itineraries protocol. And it could include things like your reservations at restaurants and your tickets to events, and you know, your car reservation rental, and you know, plane, you know, all that stuff you need to do to travel. And all of those things can be within your personal data store, and you can permission them. You can permission certain companies, like for instance, the companies indicated here, like car company, airlines, to be able to send you the things that they typically would have forced you to go get another app, not because they love it. There's actually huge downside to that. A lot of people don't install these native apps. It's a freeing thing, the ability to have that data pushed to you, to the hub of you, which is these personal data stores, and then be able to permission apps to be able to use that data. It's just a very different paradigm. And then lastly, like a more personal web, like, you know, I moved recently, and you know, a couple of years ago for the second time, and had to change my address everywhere, right? Wouldn't it be a lot better if I had a personal data store that was accessible with permissions, so that all those places that typically I would want to have my address would be able to have permissions to it, and they'd automatically get updated, right? That's the power of a personal data store. Very hard to do in some of these other social feed protocols because they're really not designed for that. And I think that we spent a long time creating a structure that can support all of these things. So what's the main event here? What's the meat to this? DWeb nodes feature this interface called protocols. There's not very many things in a DWeb node. There's only 3 distinct interfaces, we call them. One is records, the bare records that make up the data. The other is permissions, so how you permission the data. And then there's also this protocols interface. And protocols is really interesting. If you can kind of see here on the slide, this is a very simple one. We're going to walk through a much more complex one live. This is a protocol that you would install in your DWeb node as a user, right? You would say, hey, like I want to do to-dos in this case. And super simple protocol here that just has a bucket, this sort of URI where all that data goes under. It goes in this bucket. It's got just 2 types for this very simple protocol. The to-do type, which is a JSON object, and a collaborator type. And collaborators down here, you can kind of see this structure. We're declaring what the shape of the app is and their relationships. So we have under it a to-do. You can see that it's the same name here, to-do. And it's saying that, you know, underneath this to-do, there's these collaborator.
Freezing up again a little bit, Daniel. Oh no. Yeah, I'll take over a little bit from here. So as you can see, you have a collaborator role. It's set to role true. And what that gives you is you're able to give someone this role of being a collaborator as a part of this particular to-do. So in this case, as you can see, right under there, it says actions, right? So the actions for the to-do, a role of to-do collaborator can update and delete a to-do. So if you've created, a to-do and then you add someone else as a collaborator, they now are able to update that to-do or delete it. And that's that's where they get the permissions, right? So as long as they are the recipient of that collaborator record, they're able to interact with that particular to-do, and the DWN enforces these rules to only allow them to update and delete.
And one of the cool things about this is that you can create your own protocols. You are crafting the to-do protocol, or you're crafting the music protocol, right? You're not proposing something to a bunch of people and hoping that they like what you got, and maybe if it's just so, then you can maybe deploy it, and then you got to convince all these large sort of centralized aggregator streamer places that, hey, please, sir, accept my proposal. You don't have to do that anymore. You just craft your own protocol, and you can actually install in your own DWeb node, even if it's a hosted one. And the host doesn't have to know anything about it. right? You have the full control to do that. So you have your own space for app development, and you can install whatever apps that install whatever protocols they need. So that's kind of what's shown here on the right, is that you would install a protocol. Usually it's an app going to be requesting this. They're going to say, hey, I'm a to-do app. Do you already have the to-do protocol like installed in your DWeb node? And you'd say, oh, no, I don't. And so you would install it in your local and your remote. They would sync. And then the app's then able to start, doing some to-do things. So
yeah,
I think, go ahead.
I wanted to also mention that, most apps will have multiple protocols that they deal with, right? So you might have a profile protocol as a part of this to-do app as well, where it has some information about your profile and things like that. So, you shouldn't really think of protocols as the app. It's a piece of the app that kind of describes some functionality.
So that was a very simple protocol, but we're going to get a little bit more complex here, and we're going to really dive into this. That was very, very truncated. There's a lot more power than just roles. So let's jump through this. First off, this is a protocol object. This is what defines a protocol, kind of as you saw in the last one. You can have published or unpublished protocol objects. So people might want to keep it a secret that they have certain protocols installed, right? We wanted to make sure that privacy was always at the forefront. This protocol is, a blog protocol. What you're going to see under types is it's declaring all the data types that are present in this protocol. You can just see like all the things you'd expect maybe for blogs, right? Posts and comments and media and stuff like that. And then under it, there's the structure, and the structure tells the DWN how to enforce this protocol. The structure says there's this global role called follow that you can assign to people, even like you're following someone, right? There's an admin role, right? Maybe for the blog, this is a commercial blog and they have admins for it. There's an invite. Maybe you can invite people to become an admin or to do something. The idea that anyone can create an invite is represented here, right? We have a couple, these are ideas. These particular action verbs are ideas, expiry and gate. We haven't coded them yet, but we've had them on the drawing board. Expiry, maybe saying like, you know what? Invites, when they're sent, they drop off after a day, right? They just go away. They're purged. Gate, proof of work gate. You don't want to deal with DDoS and you want it to be in a decentralized way. You might do a proof of work against your record that you're trying to write to someone's DWeb node, and it's gated by proof of work. Liren, you want to walk through this a little bit?
Yeah. So another type of we have a block kind of record, and you might want to block someone. So this would be kind of where that would be. And admins are able to delete or prune blocks. And we'll go into what prune means. Prune is more useful for purging kind of things under that graph point. So if you have anything under it, it'll also allow you to prune it.
Okay, and so now we're down here to a blog post, right? So I'm using those objects from up top and I'm declaring it as a post here. And I'm saying, you know what, the max size of my blog post is going to be 5K, no bigger than that, right? The text part of my blog is being 5K. And I'm going to declare it.
I want to make sure people understand. So when we say that, that means that if you try to send a post to my remote DWN, or even I try to write a post to my local DWN, if it is larger than that, it will be rejected. It's just not going into the set at all.
Yeah, and these are dynamic rules. These are rules you can write. You basically are declaring, and the DWNs enforce these rules because this is the shape of your protocol. This is what constrains your protocol. So in this case, yeah, we're relatively terse blog posts, and that's just for the text. We might say, hey, there's some tags. Liren, you can talk about tags. You're the one who developed.
Yeah, so tags are a pretty flexible way.
So you might as well, I suppose, go through it.
Yeah, tags are a pretty flexible way to add some more information to a type of record, right? We understand tags. They exist in many other different systems. We've allowed you to define tags in using a subset of JSON schema. So as you can see in here, we have a set of tags. One of them, it starts off with showing you which tags are required. So that means if you do not have, let's say, a language tag, which you'll see a little bit below, that post will also be rejected. We have a categories tag. So a categories tag can be an array of strings. So you can tag whatever post it is that you're making with different categories, like cooking or streaming or development or whatever you would like, and it can be multiple strings that are tied to that. And when a user would like to look up things, they can also filter by these tags, right? So they can look for posts that are cooking posts, so they'll get back a list of posts that are categorized as cooking posts. So that's an example. Highlighted. So this is just to show you that you can have just a Boolean type of tag that could either be true or false. Highlighted in a post is like, I want this post to be highlighted in my profile. So this is an easy way to kind of mark that as I write this post. And then our required tag that we had is language. So let's say you have, you want to have automatic translation or something like that. So you want to tag these posts with what language and locale they are in. And this one is required. So if the other ones, if you do not have them, they just won't be a part of that post. But required tags allow you to enforce, these tags that I've specified are required, my app will break, if I don't have them, let's say, or something like that. So yeah, it allows you to, with the enumeration, you're allowed to put in the strings, the only values that a language tag will accept. So if you put in something outside of these values, once again, it'll reject it. So it gives you, really flexible way of writing rules. I do want to make a note, right? Because, not in this protocol specifically, but you do have the ability to encrypt records in, DWNs. I'd say do not tag things that would show what that record might be if it's that. So you have to keep privacy in mind when you are tagging things, especially with things like the categories tag, right? Because you can put anything, any type of strings in there. So you may just kind of have
definitely. If you're in the UK, just put your meme text in the actual data, encrypt that, and just say meme, maybe category meme. You don't want to put the meme text outside. May go to jail. Might not want to do it. So, so let me go over one thing about posts. So you saw there was a role up here called admin. Okay. So admin's a global role. So you can give out that role and it can be used anywhere in your definition. There's other roles that are sub roles. So under post, if I scroll down here, you'll see moderator, right? So this means that each post I can assign moderators who can now do certain things within the post. And what I'm declaring is that admins, global admins, the role that's above, the posts, can create moderators. So now I can even have levels of role-based access and permissions. And again, this is all graph-based decentralized data store. So like this is enforced in a way that is very unique and allows you not to have a single authority, which is pretty cool, but yet still have permissions and access control. So this is saying, yeah, admins can create moderators. What can moderators do? Well, let's see. So I could create my own posts. The author of a post can create, update, and delete media, which we defined as like images and video above in the types. And I might even set a size limit on this, right? I'm going to say not bigger than a megabyte. I want these to be really terse and snappy. So this is going to be like images, right, that are under megabyte. And that size thing actually will reject. If you have it larger than a megabyte, this is in bytes, it will deny it. And then comments. Let's see what we can do here with comments, right? I might say anyone can create, update, delete, or prune comments. And prune is different than delete in the sense that if I deleted a comment, it would still leave things that are lower in the graph, like this, like a media object that might be attached to a comment. In this protocol that we're describing here, you can have comments that have images, right? So what this would allow you to do is delete maybe the text of the comment, but not the image it hosts, or vice versa. Prune is a little different. It's sort of like removing a whole branch structure. So I would say if I said prune this comment, it would mean delete and drop all data from the comment record and anything that's a child of it, like the media object as well. So it gives you the ability to kind of delete things in spots or whole graphs too. So in this sense, comments are open to anyone. Who can post a comment? Anyone can post a comment, excluding people that are the recipients of block objects. So that I can say, and this is something we haven't finished this excluding type feature yet. Some of these are not there, but a lot of them are. This is giving you an idea of the power that a system based on these triggers can have. Because now I can say, I wanted to open to anyone except that dude. He was really mean to me. Peter Schiff, he keeps talking about these freaking rocks. And so I'm putting him on the block list. No more comments from Peter about, your Pacific Capital or whatever. You want to go ahead and go through more of them?
Yeah, sure. As this one explains, who author of post can co-delete and co-prune. So the co keyword is actually pretty interesting. So right now where we are in the graph is we're looking at the comment part, right? So it's saying that the author of this post can go and delete and prune other people's comments that are under that post. So I think that's really important, right? Because when we do a rule of can delete and can prune, that means you can delete and prune the things that you actually inserted into the DWN. But if you want to give the ability for someone to be able to delete and update or prune, the co-keyword works with several of the other keywords, you would add it this way. So this, like it says, the author of the post can delete and prune comments that are authored by other people on their own post.
And then it also extends down to these other roles. Now you saw the role references are all based on the path structure. So if you saw that under post there was a moderator per post, what we're referring to here is which role objects are we looking up when we're doing this authorization. So what we're saying is anyone who has a post moderator, so a moderator of the specific post that we're in the scope of, can co-delete and co-prune, meaning the moderator can delete and prune other people's comments. Right. And again, I just want to reinforce that the difference between delete and co-delete means like you're doing it collaboratively, right? You're deleting across these objects. And then media, similar, right? The author can post of a post comment of the parent above it can do these things. The author can also delete. Moderators and admins can delete.
Yeah, and I wanted to point out, if you notice, we don't have prune and co-prune in media, and the reason is it's not necessary with this particular definition because there's nothing under media to prune. So delete is all you would really need here, right? So something to keep in mind.
So we've gone through some of this protocol. We won't go any deeper. I think we'll probably generate maybe some questions just based on that, and I'll go through the rest of the slideshow. So what are you getting from DWN protocols? Well, you're getting a common set of structured and binary objects, the ability to find those things that apps use for whatever type of protocol it represents. So if two apps want to party on the same structure and rules and framework, they have their users install a common protocol, and now they're interoperable. It segments the data into different buckets so that effectively you might have an encrypted protocol, like a medical data protocol, and you want it restricted from all the other data in your personal data store. So that protocol would declare that certain objects are encrypted. Another protocol might not. And the encryption keys are separate based on these structures. So even the encryption is tied to this graph structure so that if you wanted to say, you know what, I want to encrypt all my medical data and I want to give access out to the results object under a test to this one person, you can do that to give that permission away to maybe a doctor or a specialist. It includes the role-based activities, which are awesome. I mean, the ability to have roles is something that's powerful. It's a capability-based role-based access system. Like this obviously doesn't exist in 99% of other protocols that endeavor to build decentralized apps. It is hard to build. This took us a long time for a reason. Enforces requirements and limitations. Like you just saw, we have some limitations that we want to add. We have some in there now, like size and tags and actions, and we want to expand the set. So we want help from you to define like what would make it easier for you as a developer to create a protocol. And you should look at this almost, if you're a Bitcoin person, it's like Bitcoin opcodes, right? Like what opcodes should I give you as developers so that you can craft a more powerful protocol? And then devs also get, and I'll show it on the next screen and a live demo, a per protocol REST-based API for free. And that's going to make a lot more sense when I describe it in this next slide. But you get a REST protocol based on your protocol you described for free just by crafting one of those JSON documents and installing it. And so what we think is that this structure enables more rapid permissionless protocol development. Less asking people, less high priests. I don't want to go to some project maintainers and beg them to please like let me have an object with this tag or please index it, sir. Like none of that, right? Like go and build your protocol out, right? Install it in your DWeb node, have users of your app installed on theirs. You can do it completely ground up grassroots. There's none of this, this tribal gating. So one thing that's amazing about, I think about DWeb nodes and kind of they're harmonious from all these sides is that we've created ways to expose them that are really unique. One of these unique ways is DRLs. So these are decentralized resource locators that actually work in the web of today. We have a very simple polyfill that you can call, this one function out of Web5 API. You just call the function and it fixes your web environment up to have all these cool capabilities. So what is a DRL, right? Well, a traditional URL is based in the CA system. So all the trust and security comes from the CA system based on HTTPS, which is going back and talking to certificate authorities, right? And that's a hierarchy of authorities who dictate who gets this thing to the right here, which is a domain name. So domain names, even for companies, even companies like Microsoft and others that are worth $1 trillion, they still don't own their own domains. They don't own their domains. They could be taken from them. They are leasing an identifier. And we don't like that, right? We don't like that anyone has to have their identifier leased by, ultimately some government, which we see all the 3-letter agencies with their beautiful logos taking down all sorts of sites, not with DIDs. Your DID is independent from all of those things. It should be yours. It shouldn't be under the thumb of any hierarchy. The next thing over, Alice, right? She's just a row in centralized apps database. Like this, she's nothing. She loses this ID in a second. On X, some dude had the music handle. He lost music, right? Like gone, rug pulled. Never happens with DIDs. And then, of course, every website just comes up with their own REST API, which they might have the same exact 2 apps that do basically the same thing. Of course, they're different APIs. What is a DRL? Well, it's from the DWeb. So this is an actual way a DRL looks. I'm going to show it to you live here in a second. Instead of centralized usernames and domain hierarchies, we have a DID, which is the locator for your DRL. So imagine like you're not looking up a domain name as a browser anymore. You're going out to the DWeb and finding the routing endpoints to a DID to go find where its DWeb node lives and pull this content down that's indicated by this protocol path here. And you can see that that to-do path is the same as I described in our simple to-do protocol earlier. The structure of your protocols, as you kind of saw with blog, right, comment, media, right, same thing with to-dos, to-do, is exactly mirrored in a REST API that you can hit any DWeb node that has those protocols installed, and they sort of work for free. So I'm going to show you, before we get to this guy, which is a cool announcement we had, I'm going to show you a real deal protocol here. So this is an app I've been writing. It's a social app called Follow. It's getting there. We're almost ready to put it out. When I say we're, I mean me, not like it's Block. We're not putting out a social media app, but I will be putting out this app, and I think it's pretty darn cool. All the data you see here is stored locally in my DWeb node and is on my DWeb node. All of that is stored in my DWeb node, which is awesome. I have control over all of it. I'm not anon anymore, so like I might just want to change my name. Let's just change it here, and it just saved right there to my DWeb node, right? And it's syncing out to my other DWeb nodes, remote and on my other devices as we speak, which is pretty powerful. And I wrote this Magic Internet Apps blog post, and I've got these pieces of text I can add here. I can live edit it. I can go down here and I've added this other image, and I want to show you something special about this image because it's a very special image. It is showing off what a DWeb DRL looks like. So if you see this URL right here, it's a pretty special URL. Go ahead.
Can you make it a little bit bigger?
Oh, bigger?
Yeah.
Yeah. Okay. So this is an image, okay, right here. And you can see it's very, very different. It's got a DID. It's got the record ID. It's a big hash, effectively. And what's happening here is the polyfill that you activate actually makes this work. So the browser is now understanding how to look up a DID, find its personal data stores that are attached to it, and then go send a query in DWeb terms to be able to fetch this data that you just saw here. This is actually coming from a remote DWeb node. And this URL was used by the browser to locate it and pull it down. And I will show you exactly, let me show you a couple examples here. So here is me looking up a DID. So I'm going to look up a DID with just fetch. This is just native fetch API, right? It's going out to BitTorrent for DID DHT. It's looking up the DIDs, keys, and endpoints. And this is someone else's DID. And it delivered them to me. And I get to see here through, I've got my verification methods. This is all my keys from this person if I wanted to challenge them to make sure they were who they said they are. Here's my service endpoints if I want to go, maybe to a place where this data might exist for this person. And so I can do that. I can also look up, and so this is the person we're looking up, by the way, Pablo. He has his own stories and stuff here. I can go ahead and take his did, in fact, and I'm going to go look up his did. So let me grab that guy. I'm going to go here in this other tab, completely separate localhost tab. And let me go ahead and look it up. Let me make sure this works for this app. So I'm going to type his did in. What's happening is it's doing a query, and it's going to go pull Pablo's profile. It's from his DWN. I just went and pulled it from his data store, showing it off here. Pretty freaking cool. And I can even go and query Pablo's his stories. So let me just go ahead and do that, right? So I just got it back. Array of one entry. This is actually the story that you saw here. Pablo published it to his DWN. I was able to query for it, and I was able to do it through a regular old URL. That's pretty cool. So yeah, DRLs coming to a browser near you. In fact, they're available now. If you go grab the APIs, you have one line of code, and now you're able to get anything from the decentralized web, any content anyone publishes. There's no, Liren, you want to talk about maybe the discovery piece? Because I know that's near and dear to your heart, the difference here.
Yeah, I mean, when you mean the discovery piece, it's I don't need to, I know exactly which server in the cloud or wherever I'm going to pull the data that I need, right? Usually some with just regular public key kind of encryption or public key identification. I don't know where the data lives. Like, yes, I can validate that it was uploaded and signed by a certain person. I can attest that it wasn't changed and things like that. But where do I go get it? In some other systems, you kind of either, it goes to one or two places. You either rely on a centralized directory of sorts or a fire hose of sorts, or you kind of go and ask everyone for it and say, hey, are you a part of this? Are you a part of this? And that's a problem, because that can defrag where data is. Because maybe I did use some other endpoint and publish my data there for a while. Then I changed my mind. So you found my profile on this other relay endpoint, whatever you want to call it. And you found it, and you're like, oh, cool. I know this is where Liran's data is. But guess what? I stopped publishing there. So with DIDs, the first thing I'm doing in this whole step, when you look at this DRL, first thing I'm doing is I'm resolving that did DHT, and that's giving me back service endpoints and keys to be able to go and fetch this data.
All right. So last slide here we'll cover before we start taking questions. Just so you know, we worked with Google and Diff on an initiative to bring DWeb nodes for free, a free instance that's out there on Google Cloud. This is pretty cool. I mean, it's sort of like if they, if someone ran an Nostr relay or an app protocol, but like it was like maybe one of the largest web companies in the world. And the thing, maybe this sets off alarm bells. People are like, oh, Google, we don't want Google. Well, someone's running the outbound replicas, right, of things that you might want to aggregate or push stuff to. So anyway, you cut it. In Nostr, they're pushing it to relays. Those aren't magical, fairies that are out there for benevolence. They are servers. So you need those things to exist, it turns out. And Google actually stepped up and was like, we'll host them. Now, the cool part about it is any data you want to send out there that's encrypted, obviously they can't see. It's not like they have any keys. Public data just makes it easier for your people who are following your blog, for instance, in this other protocol we crafted, to find your stuff, right? You're not always online. Like my phone might be offline. It might be, on an airplane. Ideally, DWeb nodes can be addressed peer-to-peer. Like you could actually dial my phone, but I'm not always online. I might sleep, I might turn off, right? I might want a replica that has a certain subset of my data out somewhere highly available because I want people to be able to find it when I'm offline.
I also want to point out that that your DID document can have multiple DWN nodes tied to one DID, right? So it's not like if you're using Google's DWN Cloud DWN, that's the only DWN you're addressable as. You say, what, Google's giving out this free service. Sure, I want they'll be the first one in my array. They'll be the one that everybody hits and all the traffic goes, and they can incur all that cost. But hey, what if they're down, or what if they stop responding for my DID for whatever reason, right? So you can replace that endpoint whenever you want. You're in control of your DID, but you can also just have 2 or 3 or 4 or 5 endpoints up there, and your data will be synced across all of them, and any one of them will be able to serve up this this data.
So let's reserve the last 15 minutes for questions. I know Tanya said there's some questions. How can people see what other protocols have been created so we can piggyback on them? Great question. So one of the cool things is if you publish your protocol to your DWeb node, just in an ad hoc fashion, if you know a friend, you can actually look up and pull down their protocols if they're public, right? They can say you can say, oh, does Billy have this protocol installed? Maybe before I try to send him some data that it adheres to those rules, let's see if he even has that installed. So you can go query a DID and find all of them.
Or you could even, instead of saying a specific protocol, like you said, you can just say what protocols
yeah, what do you speak?
Bob have, and you get a list of all of them, right? So all of the ones that they've designated as public.
Yeah, and where could we house them? I mean, we can house as an index or a directory of protocols. We could house them at any number of places. We can house them at Are We Web 5 Yet? areweb5yet.com, just places where people can discover them, and other coordinating areas like maybe the Decentralized Identity Foundation. But you can also, we could have a DID technically that has its own DWN, and it could be the protocols DID, and I can actually assign keys to multiple people to control that ID, and they could publish it in a very decentralized way that's not bound to any website. So
yeah,
it's a little heavy, but
also, I'll mention one of the community members, Andor, who's also one of the chairs of the working group for building the spec, had put together just a little site. It needs a lot of love, where he wants to have this discovery of protocols, where you'll be able to look at I think the way he also has it separated now is its namespace, like protocols that are still kind of being played with and are not solid are dev, and then prod will be these are already kind of in use and out there, and you can use them for things. So yeah, I think there's going to be a lot of different ways to discover these protocols. And I know an interesting idea that you and I, Daniel, have talked about before is allowing the user to also share not only what protocols they have, but what web apps they use with those protocols. So it's like, oh, cool, I go to Bob and I see a list of protocols that he has. Well, how do I interact with these protocols? Like what web app should I use? It can actually include a list of web apps that they use personally with it. So it's like, oh, I have this to-dos protocol. Bob has a to-dos protocol. Wait, Bob is using this other app for his to-do protocol. Let me check that out. And I think that's really cool. I think it's going to create a really, really interesting way to discover protocols, applications, discover new things on the web. Yeah, I really like that idea. So this isn't there yet, but it's something that we've talked about and we're hoping to include in the near future.
Yeah, so the ability, basically, you pull someone's thing down, you've never seen this protocol before, but you want to experience it, suggestions on what apps are actually adherent to that protocol, so that if you land on the page, you can then visualize that user's data. These are all ways that discovery needs to happen, and that we need to make this whole situation better. So yeah, put a lot of thought into it. Was there any other questions, I guess? In the future, same question. Yeah, we definitely hope so. We'll popularize the ones that we do. Follow, which is that social app I'm doing, as sort of a generic social app that people could use as a basis for their protocols. There's a couple other collaborators in the community who are writing clients for it, and I should have this thing released. Liren this week giving me my last API, so it should be counted in weeks and not months. Now that I have what I need, but yeah, look for that in September. It should be done.
Yeah, I think a rating system is actually a good idea. That would be cool to have, right?
Yeah, you can. Yes, follow is a PWA. It's, in fact, we call it a DWA, decentralized web app, because it's effectively like in a PWA, you might have just regular old IndexedDB, some persistent stuff, but not a data store. With a DWA, we give you this service worker that actually enables things like the DRLs and storage locally and caching, so that the offline stuff, interactions with other people's data stores, is automatically cached. So it makes it feel very snappy and offlineable. Even if you're interacting with peers and you go offline, you could still maybe do requests out to cache resources from other people's data stores. Yeah. What is the upgradability of protocols? Yeah, so this is a big one. Yeah, the idea here is, and we are working on implementing this, is that you could change things. Let's talk about expiry. Okay, let's say I wanted to change the expiry of my invites. I want them to be for 2 days. I would reconfigure my protocol. I would take a protocol configuration and I might change this. I might say, let's make this a lot longer, right? Double the time, 2 days, two something days. What occurs is when you would create a protocol definition, a changed version of it, it would get inserted into your data store, and all of the records that came before it would be applied to the previous set of rules. The new records that came after it would be applied to this new set of rules with this change, right? So that they would be held longer, or that maybe it's size, right? Maybe I want to double this, right? So it would mean that all the records that come after this, effectively this almost like an active, if you're a Bitcoiner, think about it like in block activation time, right? You're like, there's an activation of new rules, right? That takes place here. And then every block that builds on it, every transaction has to be adherent to those rules or can use those features. And that is what we're going for. Obviously, it's not a blockchain. It's just good old, well, not good old, it's really difficult, very laborious distributed systems work. But yeah, in the end, you get what feels like magic, the ability to sort of re-architect your protocol, because some protocols do offer optionality. Think about a protocol with DMs. Some people have DMs on, some people have DMs off, right? You would go set your protocol configuration to either expand a set of actions, like when we say actions, like what people can do or not for DMs. Maybe you turn it off, you remove the anyone can DM me, right? Or maybe you say it's only friends can DM me, people that have a friend role that I've assigned to them. A lot of power there. How do I find stuff? How do I discover content from bloggers and people I subscribe to? Well, yeah, you would go to any number of websites that have the Web 5 capabilities active and basically present in your browser. Either they're doing it or the browser has augmented it. We have web libraries for this, and apps could support, websites could support multiple different protocols. Like there's a website could say, oh, I understand the profile protocol, so I'll show basic profile stuff. Oh, I also understand career profile, which is like LinkedIn type data. Kind of like my app does, right? This app actually understands 2 different types of protocols. One, which is all this stuff you see here. And then another, which is the stories the blog posts that I actually have. Those are 2 separate protocols. So you could have a website that says, oh, I understand all these things. Come to me and you can introspect other people's stuff.
I think this question is also kind of asking, which is something that we've talked about before, is the concept of aggregators, right? It's asking like where, so if I want to follow someone like a blogger or this, or just discover new things, like where would I go to do that? And aggregators is something that we've talked about. And an aggregator could just be a DID, right? Like you can have a DID that people know, or several DIDs, right? That you're like, oh, some, social aggregator, or some whatever aggregator, blogging aggregator, these different types of aggregators. And I publish it to my own DWN, but I'm like, I also want the world to discover this thing. So I'm going to push it out to maybe 3 or 4 or 10 different aggregators that I want. And as Daniel's showing, you can show, you can put roles and rules around like what aggregators can do, or what, the type of roles and actions and stuff that you can do with it. The aggregator themselves can also do these rules. And then you can have a protocol maybe, or something like that shows which aggregators you are a member of, right? And then users can look up your DID, they can look up this protocol and say, oh, this person they're a part of like 4 different social aggregators. I have other friends that are part of like 2 of these aggregators. I'm going to look at these 2 aggregators all the time and just pull down data from them.
So what this would be in practical terms, and this is the follow protocol, by the way, that I created for the social media app. If you write to the aggregators object, you can publish it, right? So you can do any record you can publish. You don't have to just do these coarse things. You can actually publish an individual record, even if the protocol structure says, oh, no one can read this. If you publish a record, anyone can read it, right? So I would publish my aggregators record, and I would put the other larger DWNs, effectively, in Nostr term relays, right? That I'm also syncing my data to. And that way someone could hit my DWN, pick up my configuration file, find all my aggregators, and now they can go to these more high volume, places that I'm posting to.
Yeah, and this makes sense, for the more technical people out there, that you don't want, if you're building a mobile app, you don't want to have like, 50 different WebSockets or 100 different WebSockets or 100 different requests, whatever fetch requests, whatever they are, constantly going out to, hundreds of different servers. So the aggregator will allow you, to look for, a smaller set of DIDs that aggregate this data for you, right? Social data, I don't know, recipes, right? There could be a recipe aggregator, right? And you go and choose that and you get a bunch of recipes from people.
Yeah. So yeah, I mean, I think we've showed a lot. I don't know if there's any other questions maybe from the.
Where does encryption and decryption happen when it comes to published data, and when you allow other data to access your information? So I mean, encryption happens all on the client side, right? So you as the writer encrypt that data. You encrypt it to using, you derive a key of that particular point in the graph that you are looking to encrypt, and use that key to encrypt it. Now, when someone wants to decrypt that, right, they look and see public keys in your graph point, and they're able to they're pretty much able. I'm able to encrypt a private key, a data key, to someone else's public key and give that to them so that they can then decrypt this part of the graph.
So this is so one thing to show you here is, like, let's say I had a medical protocol. Obviously I want to encrypt it. I'd have a medical test object up here. Now, one really interesting thing is that we have an encryption scheme that's built into DWNs. It's a derivation-based encryption scheme, sort of like if you think in Bitcoin terms like HD keys, right? You have your master encryption key that's tied to your master asymmetric encryption key tied to your DID. But you don't want to give out that public key and have everyone encrypt files, to that wrapped key, because that means that everything is going to be encrypted to that, right? And this is segmenting data across like very, very private things and super public things, right? So we don't want everything encrypted to one thing. So what happens with the derivation scheme is the first derivation path is actually this string, the protocol URI, which gives you a derived child encryption key that now is scoped to this protocol, right? And if I had a medical, say a medical protocol, the next level down would be this string, which I use as the path for derivation. What it means is that all the way down the graph, like if I wanted to have encryption for all these objects, there's a different derived public asymmetric encryption key for each one that you would see basically populated in this configuration. And so if someone wanted to send you an encrypted record, they would go fetch your configuration, grab the appropriate key, like, it might be all
Yep, Daniel is frozen again. But you mentioned, it might be a key that's for a specific piece of media, and you only want, you're uploading that. So you would look at this piece of media and you would grab the public key of that piece of media in that tree, and you would encrypt the data to that public key, and you would be able to insert it into Daniel's data store. And then when he wants to decrypt it, he's got the private key that's associated with that public key. He's able to derive that private key and then decrypt that data.
Okay, I'm back. Yeah, you probably described it, but effectively, yeah, you have keys all the way down that are derived keys, child keys from the main key you have. People go look up the appropriate key for the type of object they're sending you, and then they send you that piece of data. Because the one cool part is you could permission all the way down here, right? I could go all the way down here to bar, right? All these different data objects, and I could permission someone just to have access to bar. So I don't want to send them the encryption keys from higher, right? That had to have access to everything above it. I want to send them the specific child derivation key wrapped to their key at the level of data and access I want to give them. Which is, yeah, I mean, this was a tough thing to put together. How would you build a social graph on it? Yeah, you could have a protocol called contacts, right? You could have a contacts protocol, and you could add people as contacts, their records where they're the recipient, and maybe it's a role also, so they kind of have some power as one of your contacts. And then other apps might ask for, hey, let me see your contacts. It's kind of like phones do, they're like, you go in your car and Bluetooth and it's like, can I have access to your contacts? I always say no. I don't know why phones are like, I just like stuff being on my phone. I don't trust any of it. And so I deny it. But this is the same thing that you could do here. You could put all your contacts, you keep them, and then different apps that might need contact awareness ask for permission, right? They say, hey, give me read, write, query, whatever it is, to that particular subsidy data.
And yeah, you can crawl, and you can crawl these things, right? So I'd go to Daniel's if he gives me access to his contact list, or maybe he has public contacts. I'm able to see those, and then I'm able to go to each one of those and ask for their contact list, and so on and so forth. You can really just crawl and make a giant graph of this.
You can crawl the DWeb. Yeah, you can definitely crawl, and you can follow DWeb links to other data stores, and actually, create your own sort of little Dougal, I guess it would be. Is there a spec or code for running an aggregator? So let me fuck your mind up a little bit. It would be a little bit of a trip. An aggregator is not special. It is literally just a DWN. I know it's kind of trippy, right? It's literally just running a DWeb node at scale. Because when people have an aggregator, they're just sending, the aggregator has the same protocol installed, this exact same protocol in a DWN. They're just allowing more tolerantly with their protocol rules for other people to post to them, right? Maybe they have a member object if they're an aggregator, right? They have like a member of the particular thing, and they're going to set that up as a role because they're going to charge for it, right? Maybe they charge you or something to be an aggregator, and then they add you as a member to their thing, and all of their post stuff is gated on whether you're a member, right? So they get to decide, but there is no difference between an aggregator and a DWN. It's just a DWN.
Yeah, and in the near future, we're looking to create as a part of a companion guide. We're gonna have some like common patterns and things like that, and aggregator is gonna be one of them to kind of explain it a little more. But it is gonna be pretty simple because it's just like Daniel mentioned. It's really just a DWN and a DID that we reference as an aggregator.
Yeah. Cool. So when does the social media app drop? I'm busting my ass to get this thing out. I was waiting on a couple APIs. They had me in the first quarter, but the second half I think is going to be good. So next month, it should be there. A lot of functionality is already built out. Like I've already done a lot of it. I was kind of polishing the rock a little bit, waiting for a couple other pieces of the core tech to be done. But I should be able to slap that in super quick. So yeah, September. And the cool thing is, one other thing, we have the ability to actually store your DIDs in the browser natively, which is pretty awesome. I'm not going to show it, so you don't have to show the screen, but that's coming. So your native password manager can manage your DIDs, which is amazing. It'll, just like it syncs passwords to like other devices, it'll sync your DIDs. So you can actually log in with the native password picker and everything. No extension required, no special browser, nothing. Just straight up, just absolute hackery. Disgusting hackery to make that happen. But yeah, coming in September too.
Lots of things coming in the works. It's been a long while, and we've been
my friend, slow.
It's it's just a lot of pieces to build, and finally everything is kind of coming together to be able to really build expressive apps on this thing.
Yeah, cool. Well, I mean, that's all we kind of had. I don't know if there's any other questions. We can catch you guys in Discord. Like if you want to ask more questions, just pop into Discord or on Twitter. I'm super libertarian. You probably don't want to follow me. It'd be like pretty off-putting. But you could do it if you wanted to. Live dangerously.
Yeah, I'm a little bit less, I don't post, crazy stuff, a lot of Bitcoin stuff on my feed. But yes, you're free to follow me as well.
All righty. I guess that's all she wrote.
All right. Thanks, everyone.
Talk to you later.